Приветствую вас на воркшопе моего коллеги Пабло Агилара. Сегодня он расскажет вам про Dry Python, про то, как его пользоваться, про те идеи, которые лежат в его основе, и также покажет некоторые новинки с нового релиза, который еще не на PyP, но скоро там появится. Итак, я жду своего коллегу в эфире, чтобы представить его. Hi, Pablo. It's really nice to have you here.
Oh, thanks. It's a really pleasure to be here with you today.
Pablo is my colleague from Brazil. Open source really makes this world really small and unites people. So thanks a lot, open source community, for this opportunity to work with Pablo, with other people from all over the world. It's a really big pleasure for me. So, Pablo, let's start with the talk. What do you want to tell us today?
Before we move on the content, let's introduce myself. There's a quick introduction. My name is Pablo Aguilar. I'm from Brazil. Currently, I'm enrolled as a software engineer at globe.com. And how Nikita said, I'm one of the Dry Python core developers. Dry Python is a open source organization that provides a set of libraries to help us write a better code. And I will show one of the libraries we provide. So the main goal of this talk, the secret meaning behind the title, is not about the startup agreement or something like. Is divide the code and conquer maintainability. I think that this topic is so important because a maintainable code, it's important, not because I want or you want or someone else wants. It's because we need. Along the years, the complexity of our systems grew up. And not just because the technology, but because our business logic as well. Time is money. So if you have a maintainable code, maybe we reduce our time to release something, reducing the bugs as well. So we can divide our code in many ways. Sometimes this division is called a design pattern, like a singleton, faced, or chain of responsibility. We also have the architecture design patterns, like MVC or MVP. The difference here between design pattern and the architecture design pattern is the level of granularity to deal with. But in the end of the day, what it really matters is how we can organize our code, because our code have to be understandable, maintainable, and team-friendly. It's because we don't write the code just for us, just for ourselves, but we work in generally. We don't work alone. We work on a team. So we can organize our code in many ways as well. Like I can organize my code, dividing using functions, classes, files, or models. And here in this talk, I want to talk about an architecture design pattern and the railway-oriented programming too. I will show now a code example of code organization that I experienced with in my last job. So let's start with a simple example here. The Flask minimal application. If you go to the Flask site now, you will see this example there. So Here we just have the Flask instantiation and a root road that returns just the string hello world. So generally we use with our application, we have to add the database. We can use SQL, can we? So if I introduce the SQL in here, you have three things in this file. The application setup, so I'm instantiating the Flask application, instantiating the Flask SQL can be, and everything else. And I have my database model here, and my application row. So now we have one more row here, /users, that query on the database and return our users we have. But sometimes we need to validate the request that incoming to our application. We can use Marshmallow. So if I introduce Marshmallow here, you have something like this. Just one more import, the Marshmallow import, and the Marshmallow schema class. So with the Flask database and Marshmallow, we can write a road to create users, and I have something like this function that it's a kind of simple function. I don't have so much to talk about, but if you pay attention in this function, we have basically three different things in the same function. First, we have here the request validation. So we have a business logic validation. Here it's just an if statement, but can be many statements, and can be more complex. Just an example. And we have the database interaction. And finally, we return the user. I know this example, maybe we can say that I can divide the code, separating the modules in a separate file, the Marshmallow schema in a separate file, and the Flask application setup in a separate file too. But we keep this road as is. Sometimes we don't care about. We just keep it, and in this previous example, I can see a lot of issues here. But if you have a complex business logic, this can be a kind of word. So we have to choose an architecture design pattern to deal with these problems. And if you do not choose the application architecture, other people will choose for you. Initially, we don't care about what architecture we will use, but this is the worst decision we can make, because this is the future of your application. You and your team, you provide the maintainability. So sometimes these people can be your framework. So we have a big example here. When you type Django admin start project, it creates a boilerplate for you using the MVC architecture. And first of all, we don't care about this. We just start writing our application in the MVC architecture without thinking if this architecture is the best for your problem. I'm not saying this approach is wrong. We just have to stop and thinking about if the data architecture fits with our needs. So here I want to talk about the clean architecture. The clean architecture, the clean architecture was proposed by Rob C. Martin, aka Uncle Bob, in 2020. Yes. So this is the basically schema extracted from Uncle Bob blog post. Just a disclaimer here. I don't care about if this architecture will be applied to a monolith, a microservice, or nanoservice, or if I use a language that supports OOP or functional programming. It's just here is just an abstraction. I will talk about the layers here. The first layer I want to talk about is the entity layers. Generally, these entities encapsulate the enterprise business rule, like credit card number validation. They won't be affected by external changes. If the entity is the most inner cycle here. So if I change something in the interface adapter layer, they won't be affected by. The next layer is the user cases layer. All of the business rules lives here, and a use case represent a business action. So we shouldn't have a class named like payment that process the payment, delete the payment, modify the payment. We will have you can have a class with like a process payment, and another separate class for deleting the payment. In the layer, we'll have the business exceptions as well, and we define here the interfaces, like a data provider interfaces. So I told the entities encapsulate the enterprise business rules, and the use cases the application business rules. But what is the difference between these business rules? The enterprise business rules is present in more than one application. So I can have a credit card validation in more than one application, while the application business rules is just present in one application. So we have another interface adapters. In this layer, we will implement our interfaces that will be declared in the use case layer. Here, it will receive the most convenient data from the use cases. Will transform to most convenient data to your interface. That can be an interface with the database or with a REST API, and convert back to the most convenient data to the use cases. The last layer we have is the frameworks and drivers layer. This is the outmost layer of the clean architecture. Generally, in this layer, we leave our frameworks configuration, like a web framework configuration, a database configuration, our dependency injection framework configuration. in this layer, we glue, it's kind of glue of everything together of the older layers. And this is an important rule we have in the clean architecture. It's called a dependence rule. I'm going to go back to the schema here. So the dependence rule here is represented by these arrows in the cycles. The dependence rule tells us the most inner cycle can't know about the outer cycle. So entities can't know anything about the use cases, and the use cases can't know anything about the interface and adapters layers. You have to respect this rule to maintain the architecture in a good form. I brought this quotation from the Uncle Bob blog post. Basically, he said here to be pragmatic and not a dogmatic person. This schema that I showed to you is not the final one. You can adapt the architecture for your problem. I brought just the 4 benefits here, but we have more benefits, like frameworks are isolated. So one thing I want to talk here is everything outside the use cases and entity layers is just a detail. Our frameworks that I use is just a detail. What really matters is our business logic. So we can't discuss about the framework. First of all, we need to discuss our business logic. So we have a clear business logic, because the business logic I encapsulated in the use case layers. So yes, our business logic is the use cases. It is a good for monolith. I have experienced with monolith using clean architecture, and I can tell this is a good decision, because when I have to transform some components of this monolith in a microservice, I basically copy and paste to another project and go start, and everything works okay. And it's easy to test, because we don't have many interdependencies. Our use cases are isolated. We don't depend directly from data sources or something else. We have the cons as well. Generally, all the architecture design patterns are abstract, but I think the clean architecture is too abstract. Is more abstract than the others. Here we have a many abstractions decision to make, like where do you have to put the authentication? For me, the most clear idea here is I have to put the authentication in my interface and adapter layers, because my framework is there. My web framework is there, so I can validate authentication the request that incoming to me. But in fact, we have to put the authentication in the business logic, because this is an application rule. And we need to have a mature team to discuss these questions. We can have the code duplication. Like I have an entity in my entity layer, and I have to replicate the class and its attributes when I constructing the database model. So now I'm going to talk about the railway-oriented programming. The first post I see about the railway is from F#. It's a blog called F# for Fun and Profit by Scott Washlin. I hope to say his name correctly. The basically idea here is error handling. Basically, Railway tells us that our code can take two paths. A success path, when everything worked well, like an HTTP request, database are working, my parsing validation was good, and we keep taking the failure path when something just go wrong. And I brought an example here. It's just a parse function that will pass a string, and it's try to convert the argument in an integer. So when I pass a string with 42, we work correctly because we just have an int inside the string. But when I try to pass something like a string in a string, the code will break. So here we can see clear the two paths. The first one worked correctly, and the second one broke. Yeah, and to deal with, generally we use a try except pattern, catching the exception value. So here we are preventing our application becomes in a bad state. But we can do something better. We just Python string provides the method is numeric that checks the string has just the numeric value, and we can parse to int without any issues. So here the parse function is, if the argument is numeric, we just return parsing to int, and if it isn't numeric, we will just return an exception. So to know if something goes wrong, we need to check the returned value, like in the final lines. When I have parsed string and I verify with the function is_instance if the parsed value is not an exception, because if it is not the exception, I'm on the good path. So following the same example, we can improve a bit and have this example here, where after each action, I check if the result is not an exception, and so I can go to the next action. But it's here. This is a kind of word, because we grow up with if statement if you just can have a giant try-cat here. And here, the returns by dry Python comes in. Returns provide the result container. This container abstract was the two paths, the success path and the failure path. I have extracted this example from returns documentation. As we can see, is just like our parse function when return the parsed argument or return an exception. Here, if the user exists, we just return success, and if the user does not exist, we return a failure. So if I want to convert my parse function, I can just use the safe decorator. The safe decorator here will prevent the propagation of the exception. So if I pass a valid input, I will receive back a success with my parsed number. But if I to the right, yes. Oh, sorry. Yes. So if I pass a string with a string inside, I will have a failure with my failure inside. In this case, the invalid literal for int. So I can convert this pattern here using returns just to it. Action 1, action 2, and action 3. It's a typo, but the action 3 returns a result container, so I can easily apply a function, just count the bind method, because the bind method just will want call it if we are in the success path. Just an explanation about the return type annotation. We have result, and then inside the square brackets we have any and exception. In the left hand side we have any. The type in the left hand side is the type we will return if everything goes well, and we don't meet any problems. And in the right hand side we have the exception type, because if something goes wrong, we will return an exception. So this approach of railway is we can find in many languages. It's not just Python with returns or F#. We can find it in Ruby. Ruby has the dry monoslib. Rust has a built-in type, a built-in result type. The TypeScript has the fpts lib, and so on. But why I'm talking about this? Why I'm talking about the railway here? It's because it's a good approach to make the communication between components. So our architecture is composed by components, and sometimes in a normally way we made the communication between the components. We use generally we use an exception. We have a business exception, like, oh, user does not found. We just raise users do not found, and we don't care about if someone's in your code will catch that exception. And that an exception is not just an exception. It's not an exception is a huge side effect with expensive CPU cycles. So when you have to get an exception, it's so expensive to computation expensive, and our code becomes unpredictable because we don't know where we have to put the try except, and you have a disconnected counterflow, because a try except is a counterflow, but with disconnected with its condition. Like we have an if statement, and you clearly see in an if statement in which scenario that if statement will be executed, and using try except we don't have this to clear, because the exception is in another part of our code. And I extracted this phrase from Nikita blog post about the Python exceptions. And if we think about it, when you raise an exception is just an able to statement, because when you raise an exception, he jumps to our next try catch. He totally breaks the normal flow of our code. So how you implemented the clean architecture and joining with the railway programming in Python. Before I show code, I want to show this image here. Essentially, is the same schema that I showed to you a few slides ago, but this schema here has a more practical view about the clean architecture. So we have the entities, use cases, and entities and use case layers, and to represent the interface and adapter layers, we can see what lives there. Our REST API, our job, the database, and so on. And we have the most outer cycle. This is the configuration. So to make the project, I have used these frameworks and libraries. I think everyone knows about these libraries. I don't know about the Pank or returns, but the rest is known. So how I said, that schema is abstract, and to consolidate that schema using Python, I have used the Python package structure. So each layer is in a Python package. So my configuration layer is a package, my entity is a package, my use case is a package. Everything, every layer is represented by a package. So I will show you some code now. Just move on. Here, Nikita, is the font size great? It's better? Yeah, yes. Okay. Okay. This is an entity example. It's just a data class. I don't have any enterprise business logic here. It's just a simple class representing a project. This is an example of a use case file. Here we have we are defining our interfaces. I choose to put the interfaces with the use cases. So here we're defining the interfaces. And this is an example of use cases using the railway oriented programming here. So what really matters here is this return statement here. These use cases have to communicate with 3 different interfaces, and each interface can have problem. So without using this approach of railway oriented programming, I will have something like that. The example code when I have 3 if statements to check if one interface does not break anything. So here, okay. The data provider, I will show you 2 data providers I have in this project. The first one is just a database provider. So I have this repository here, save string repository that implements the save string interfaces. So here these interfaces is from a use cases. I have another example here. Is just an REST data provider. And one thing I forgot to mention is in this project we enforce the single responsibility principle. Each class has its own responsibility. So as you can see, every class has the call magic method. So in my repository, in my use cases, and I can do this in an entry point. This is a REST entry point that uses our use cases. So the only responsibility that the entry point has is to call our business our use cases. The next one is a test. Yeah. So as I said, it's a pretty easy to test our use cases because it are does not depend of the concrete implementation. So we have the interfaces. You just have to follow this interface implementation, returning what is expected. So here I'm testing these use cases that receive free interface here. So here I have free fixture each feature representing an interfaces, and have a feature returning use cases. So I can use my use cases pretty easy in the test. Let's go back to the presentation. I have some final considerations here. Maybe you are thinking, should I use the clean architecture? I can't answer this question for you because my needs is different for your needs. You have to question yourself, does the architecture fit with my needs? If you have a simple crude application, maybe you shouldn't use the clean architecture because you are just over-engineering your solution. Another point here is the clean architecture, as I said, is too abstract. So you have to have a mature team because this is not recommended for beginners without any supervision. I talk about the exception and the problems that you can have with exceptions, but the exception itself is not the problem, because when you create an exception, we are just instantiating a class, an object. The problem is when you join the raise keyword with the exception, because this combination we will start that huge side effect. We have I wrote this tweet, Uncle Bob's tweet. I will don't read this, but basically the message that I want to pass here is don't be a dogmatic person, because the dogmatic person is blinded. They can't find the better solution because it don't care about if that thing is the better way to do. They want to do just the dogmatic way. One thing I forgot to mention here in the code, and I just go back here to show, is we have the dependence rule. So my entities can't know anything about my use cases. My use case can't know anything about the. So to maintain this, I can't import this repository here or this another one here in my user cases, because these the repositories lives in the interface and adapter layers, and the use cases is the inner layer. So I can't just import. I will break in the dependence rule. So to deal with, we can use an dependency injection. Here I'm use the pink dependency injection. I made some automation here, so I will register the user cases and data providers program automatically. And in my entry point, where is my entry point here? I think, yeah. I just resolve all the dependence of my user cases. This is some reference. If you want to know more, I recommend you to read these articles here. We can find me on Telegram, GitHub, Medium, Twitter, under the Pablo Aguilar username. And thanks for having me here. If you want any questions now, and any feedbacks are welcome. This is the first time that I'm presenting this talk, so you have some feedback. Please let me know.
Thanks a lot, Pablo. It was an awesome talk. I really appreciate your efforts on working on dry Python, and especially I appreciate that you came here and gave this talk. And I know that's a big time difference in Brazil and in Russia.
Yeah.
So, what time is it right now in Brazil?
It's 7 a.m. now.
Oh, thanks a lot for making it.
Okay.
I know it was a hard one. So I had a lot of questions in our discussion zone, but they were mostly in Russian, and I was able to answer them myself. Sorry, sorry for that. But I will read some of them to you just to illustrate what were the questions and how we can prepare for the next ones in the future sessions. One person was asking for some real-life examples with Flask, AO, HTTP, and dry Python. And that's something we really want to have, but right now we only can share some repositories from other authors, and that's not something we built, and we are working on it right now. But before doing it, we actually have to release the current version. So
just about I said about the AIO HTTP. Just remember the web framework is just the detail. You don't have to care about what web framework we use. You have to concentrate your efforts in the use case.
Yeah, and more, we also have some async primitives to work with, so you can freely use the same exactly the same code for both Flask and AU HTTP without even switching a line. Like, I know there will be some performance issues and things you want to tune, but generally it's the same code because it's written in a very abstract way, and it also has some abstract typing, so just use it and you'll be fine. There was also one question about domain-driven design and how these two approaches are connected, because we talk a lot about domain-driven design, and we talk about clean architecture, we talk about railways-oriented programming, and it's not clear for some people how do these things connect with each other. So what's your opinion on this question?
I think the domain design has a more general what is the word? No, I forgot the word. But I think the granular level of how we explain the difference between domain-derived design and clean architecture. The clean architecture, I think, it's more specific than domain-derived design. Like in domain-derived design, you have your domain with a kind of like use cases, but the domain can not represent just a business action. I can't explain properly now, but if the person that made the question
Maybe I can help you, because domain-driven design is a whole set of philosophy, and there are a lot of topics in there. But railways-oriented programming is a tactical pattern. You can apply this pattern to some piece of code that needs it, and it will clearly represent your domain intent and how is your domain structured and how it should work. But on the other hand, your domain-driven design in some cases might not have this pattern, so it will be skipped, and it's okay. There is one more question from another person. Is it possible to decide either your project is simple enough and it doesn't need dry Python, or it is in this point when integrating dry Python will be beneficial for this project?
We can repeat the question, please.
How do you decide either your project is simple enough and it doesn't need dry Python at all, or it will benefit from integrating some of the dry Python libraries?
I think the idea of returns, telling about returns here, it is not to hey, I just a simple application, so I shouldn't use the dry Python. The dry Python provide the returns provide a bunch of abstractions, so we will use in your project if you need these abstractions, like result. If you want to don't deal with exceptions, and you can use dry Python returns with the result container. And Nikita, feel free to make your opinion here.
Yeah, I completely agree with you, because that's the whole point of making a library of primitives, to be able to use these primitives anywhere you wish. It's not a framework, it's not something having just a simple data type that does a very specific thing. So, but probably you don't need dry Python for simple projects, because simple projects can be written in a really simple way, and that's it. So you won't benefit from it. It won't hurt you, but you won't benefit anything significant. So that's true. So Pablo, thanks a lot for having this talk. It was a great pleasure to be a part of it.